last lesson is titration. This is one that we haven't really worked on, so I'm going to try and explain it easily. Okay? Titration. When you have, in the bottom, I'm just going to, in the bottom, let's say you have an acid. What you want to do is you have this acid in the bottom, and you need to add to it a few drops of an organic indicator. You don't want to add pH paper because that doesn't work in this. So we're going to add, let's say, phenolphthalein, which is the one that we've been using, the one that turns pink with a base. So you add it to the acid, and for now it's colorless because phenolphthalein and an acid are colorless, okay? You want to see what the equivalence is, which is when exactly it becomes neutral. How do you know when it becomes neutral? You add a base up here, okay? And you slowly add drops of the base into the acid. The moment it becomes pink in this example, because we're using phenolphthalein, that means it became a base, okay? So that would be called the end point, okay? And the end point, what you can get from the end point is just like when it becomes a base, basically, okay? The equivalence point, we find it stoichiometry, like we use stoichiometry, we use calculations to find the equivalence point. It's when it's exactly neutral, so right before it becomes a base, okay? So, we're gonna stay on this page. So what happens is we will be asked, masalan, to calculate the concentration, okay? So, okay, one more thing. This is called a titrant. The one up here is called a titrant. The one down here is called the analyte. Most of the time, we know the concentration of the titrant. We know the volume of the titrant. We know the volume of the analyte, but we don't know the concentration of the analyte. So often, this question will be used to help us find the concentration of the analyte. So the way we're going to be able to solve this is like this. We will have, let's say, okay, let me set this up 1 second. So let's say we've got this setup, okay? Let me draw it out for you. So obviously, for this lesson, you need to have the glassware memorized. That's pretty important. You need to have the steps of titration memorized. You need, actually, yeah, I think that's kind of it. Oh, you need to have, like, obviously concentration or whatever. So a clamp, you've got the stand, ignore this ugly drawing. Okay, you've got this set up. First question, what glassware did you use? You would say the Erlenmeyer flask and the Bure. Sorry, this is called a Bure. What organic indicator did you use? In this case, we used phenolphthalein, let's say. And let's say this is the equation that you had. HBr plus NaOH gives off NaBr plus H2O, but you don't really need to know this, you just need to know this. At equivalence, okay? So instead of saying according to stoichiometry, you would say at equivalence. You would use the formula, okay? So we're gonna say HBr is the one in here. We're gonna call HBr the analyte, and we're gonna call NaOH the titrant. So at equivalence, okay, at equivalence, the number of moles of HBr in the flask, I'm gonna call it, there's over 1, is equal to number of moles of NaOH, where not in the Bure, coming from the Bure. So from Bure, also over 1 because the coefficient is 1. Okay, so if we know that the number of moles equals the number of moles, we also know that the concentration of HBr times the volume of HBr is going to be equal to the concentration of NaOH times the concentration, the volume of NaOH, just because N equals C times V. It's a formula that we've learned, right? So you have that formula. We are trying to find this concentration. Now you just replace all the values that we have. Let's say we've got that the concentration of this is 0.5 moles per liter. We have volume of NaOH. Let's say we have 1 liter of this and 0.5 liters of this. Concentration of CHBr, which we're trying to find, would be equal to 0.5 moles per liter times 1 liter over 0.5 liters would be equal to over 0.5, then be equal to 1. So concentration of the HBr is 1 mole per liter, which is basically what we use titration for.